For as long as humanity has looked toward the night sky, we have wondered what exists beyond the familiar glow of stars. The universe above us appears calm and silent, but hidden within that darkness are some of the most extreme phenomena ever discovered. Among them are black holes, objects so powerful that they can bend the fabric of space and time itself. They are invisible, mysterious, and unlike anything found on Earth. Black holes do not shine like stars, and they do not reflect light like planets. They cannot be seen directly with ordinary telescopes. Instead, scientists discover them by observing the effects they have on their surroundings. They reveal themselves through the motion of nearby stars, the distortion of light passing near them, and the powerful gravitational waves produced when they collide. For much of human history, black holes existed only as predictions from physics. Today, they are confirmed cosmic objects that shape our understanding of gravity, space, and the evolution of galaxies. But what if one of these invisible giants was not millions or billions of light years away? What if a black hole entered our own solar system? The reality would not be the same as science fiction often portrays. A black hole would not travel through space like a giant cosmic vacuum cleaner, instantly pulling everything into darkness. The true nature of the threat would be far more complex. Like every object with mass, a black hole affects its surroundings through gravity. The closer and more massive the object, the stronger that influence becomes. If a black hole passed close enough to our solar system, it could disturb the delicate gravitational balance that has shaped the paths of planets for billions of years. It could alter the orbits of distant objects, disturb reservoirs of icy bodies at the edge of the solar system, and potentially change the conditions that allow Earth to remain a stable home for life. The greatest challenge would be that we might not see it coming. A black hole approaching from the darkness would not appear as a bright object in the sky. There would be no glowing surface, no obvious warning, and no dramatic arrival. Instead, astronomers would have to detect the invisible through its gravitational influence. A strange movement among distant objects. An unexplained change in orbital paths. A hidden source of enormous mass affecting the solar system. The discovery of such an object would force humanity to confront one of the most extreme possibilities imaginable. Could our planet survive an encounter with a black hole? Could the solar system continue to exist after a close gravitational encounter? And how would we respond to a threat that cannot be seen directly? To understand the scenario, we first need to understand where black holes come from and why the universe creates objects capable of such extraordinary power. Chapter 1. Born from the Death of Stars. The story of a black hole begins inside one of the largest and brightest objects in the universe, a massive star. For millions of years, a star exists in a delicate balance between two opposing forces. Gravity constantly pulls the star's material inward, attempting to compress it under its enormous weight. At the same time, nuclear fusion inside the core releases energy that pushes outward, allowing the star to maintain its shape. This balance allows stars to shine for billions of years. But for the most massive stars, this stability eventually comes to an end. Inside a star, lighter elements are transformed into heavier ones through nuclear fusion. Hydrogen becomes helium, and over time, heavier elements can be created within the core. But fusion cannot continue forever. Eventually, the star reaches a point where it can no longer produce enough energy to resist its own gravity. When this happens, the core begins to collapse. The collapse of a massive star is one of the most violent events in the universe. The outer layers of the star can be expelled in a powerful explosion known as a supernova, spreading newly created elements across space, materials that can later become part of new stars, planets, and even life. But deep at the center, something extraordinary may happen. If the remaining core is massive enough, gravity continues compressing it beyond the stages that create ordinary stellar remnants. The collapse forms a region where matter becomes concentrated under extreme conditions, creating a black hole. The defining feature of a black hole is the event horizon, a boundary surrounding it where escape becomes impossible. Once anything crosses this boundary, including light itself, it cannot return. However, a black hole is not an empty hole in space. It is a region where matter has been compressed so intensely that space-time itself becomes extremely curved. The black hole does not pull objects from across the universe. Its gravitational influence depends on its mass and distance, just like any other object. This is an important distinction. If the sun were replaced by a black hole with exactly the same mass, Earth would not suddenly be pulled into it. The planet would continue following a similar orbit because the gravitational force at that distance would remain almost the same. The difference would be that without sunlight, Earth would become a frozen and lifeless world. The danger of a black hole is not simply that it exists. The danger comes from how close it gets and how much mass it contains. Across the universe, black holes exist in many forms. Some are created from massive stars and contain several times the mass of our sun. Others, known as supermassive black holes, contain millions or even billions of times the mass of the sun and sit at the centers of galaxies. At the center of our own Milky Way galaxy is Sagittarius A*, a supermassive black hole with a mass millions of times greater than our sun. Despite its enormous size, it is located around 26,000 light-years away, making it completely harmless to Earth. But the universe is vast, and it contains countless objects we are still discovering. This leads to an even more fascinating question. Could a black hole exist somewhere in our galaxy, moving silently through space, without us knowing? Chapter 2. The black holes we cannot see. The universe is filled with objects that reveal themselves in unexpected ways. Some announce their existence through light. Others reveal themselves through gravity. Black holes belong to the second category because they emit no light of their own. Finding them requires scientists to search for the changes they create around them. A black hole may remain invisible, but its gravitational influence can leave a clear signature. One of the ways astronomers detect black holes is by observing stars that appear to orbit around something invisible. If a star moves as though it is being pulled by an unseen massive object, scientists can calculate what must be present to create that motion. In some cases, matter falling toward a black hole becomes extremely hot before crossing the event horizon. This material can form a bright swirling structure called an accretion disk, releasing powerful radiation that allows scientists to study the black hole indirectly. Another method involves gravitational lensing. Because massive objects can bend the path of light, a black hole passing in front of distant stars can distort or magnify their appearance, revealing the presence of something invisible. Scientists can also study black holes through gravitational waves, tiny disturbances in space-time created when massive objects accelerate, especially during the collision of black holes. These discoveries opened a completely new way of observing the universe. But one of the most intriguing possibilities is a black hole traveling alone through the galaxy. When stars interact in crowded regions of space, or when black holes merge, powerful gravitational forces can sometimes change their paths. In theory, some black holes could move through the galaxy without being connected to a visible star system. These wandering black holes would be among the hardest objects to discover. A star tells us where it is through its light. A planet reveals itself through reflected sunlight. But a rogue black hole could move silently, revealing itself only through the gravitational effects it creates. Fortunately, space is enormous, and dangerous encounters between stars and black holes are expected to be extremely rare. The existence of rogue black holes does not mean one is heading toward Earth. But imagining such a scenario allows us to explore an important question. What would happen if one actually came close? Chapter 3. A dark visitor enters the solar system. The solar system has remained stable for billions of years because of a complex gravitational balance. The planets orbit the sun, moons follow their planets, and countless smaller objects move through the outer regions of our cosmic neighborhood. This stability may appear simple, but it is the result of billions of years of gravitational interactions. Now imagine that this balance is challenged by an object unlike anything humanity has ever faced. A black hole enters the outer solar system. At first, there may be no obvious sign, no bright object approaching, no visible surface, no warning in the night sky, only changes in the movement of distant objects. Astronomers would begin searching for the cause. They would analyze unusual orbital changes and measure gravitational effects. Slowly, a picture would emerge. Something massive was influencing the solar system. The effect of this black hole would depend on several factors: its mass, its speed, and the distance of its passage. A black hole passing extremely far away might have little noticeable effect, but a close encounter with a massive black hole could begin changing the gravitational environment around us. The first regions affected would likely be the outer edges of the solar system. Beyond Neptune lies the Kuiper Belt, a region containing countless icy objects left over from the formation of the solar system. Farther away is the Oort cloud, a distant reservoir of frozen bodies surrounding our planetary system. A strong gravitational disturbance could alter the paths of some of these objects, sending some into new trajectories. The result would not be an instant collapse of the solar system. It would be a slow transformation, a change unfolding over time as gravity reshapes the paths of worlds. And as the invisible visitor moves closer, the greatest question would remain unanswered. How much damage can gravity cause before the solar system itself begins to change? Chapter 4. When gravity reshapes our cosmic home. The solar system is often described as a perfectly ordered system, with planets following predictable paths around the sun. But this order is not created by a fixed structure. It exists because of a constant balance between gravitational forces acting across enormous distances. Every planet, moon, asteroid, and comet influences the objects around it, although most of these effects are extremely small. Over billions of years, these interactions have shaped the architecture of our cosmic neighborhood. A passing black hole would introduce a new gravitational influence into this delicate system. But the outcome would depend entirely on one critical factor: distance. A black hole does not become dangerous simply because it is a black hole. Its effects are determined by how close it comes and how massive it is. If a black hole passed through the outer regions of the solar system, the earliest changes would likely appear among the most distant objects. The Kuiper Belt and Oort cloud contain ancient remnants from the formation of our planetary system. These regions are extremely far from the sun, where its gravitational influence is weaker. Because of this, even a distant encounter with another massive object could disturb some of these frozen worlds. Some objects could be pushed into different orbits. Others could be sent toward the inner solar system, potentially increasing the number of comets entering regions closer to the planets. However, this would not mean an immediate storm of impacts or instant destruction. Space is incredibly vast, and even significant gravitational disturbances do not guarantee collisions. The deeper question is what happens if the black hole moves closer. As it approaches the inner solar system, the gravitational effects become stronger. Planetary orbits that have remained stable for billions of years could begin experiencing changes. The planets would not simply be pulled directly toward the black hole. Instead, their paths around the sun could gradually change depending on the direction and strength of the gravitational interaction. A planet's orbit is determined by a balance between its speed and the gravitational pull of the sun. A new massive object entering that system could alter that balance. Earth's future would depend on the exact circumstances of the encounter. A distant passage might have little effect. A closer encounter could change Earth's orbit enough to create serious environmental consequences. Even small changes in Earth's distance from the sun, especially if they became long-term changes, could influence the climate system that supports life. The amount of sunlight reaching Earth affects global temperatures, atmospheric conditions, and the stability of ecosystems. Our planet's current position in the solar system is one of the reasons it has remained habitable for billions of years. But a black hole passing extremely close would create a much more dramatic situation. At very close distances, tidal forces could become significant. These forces occur because gravity is stronger on the side of an object facing a massive body than on the opposite side. Around extremely massive objects, tidal forces can stretch and distort matter. However, even in this extreme scenario, the result would not be the same as movies often show. Earth would not suddenly be torn apart from across the solar system. The destruction would depend on the black hole's mass, speed, and exact path. The reality of a black hole encounter is not a sudden cosmic explosion. It is a story of gravity slowly rewriting the rules of our familiar environment. A hidden visitor would not need to touch the planets to change their futures. Its influence alone could be enough. But even if such an event occurred, one question would remain. Would humanity simply watch as the universe changed around us, or would we have any way to respond? Chapter 5. Humanity Facing the Impossible. For most of Earth's history, life existed without knowing what was happening beyond the atmosphere. The dinosaurs never looked toward the sky and understood the danger of a massive asteroid approaching. Ancient civilizations watched the stars, but they had no way to measure the true scale of the universe. Humanity today is different. We have developed instruments capable of detecting distant planets, observing galaxies billions of light years away, and studying invisible forces that shape the cosmos. Our greatest advantage against cosmic events is not strength. It is awareness. If a black hole were approaching the solar system, the first challenge would be detection. Unlike an asteroid or comet, a black hole would not shine brightly against the darkness of space. Traditional telescopes would not simply capture an image of it approaching. Scientists would need to rely on indirect evidence. They would search for unusual gravitational effects. They would observe the movement of distant stars and objects. They would use advanced instruments to measure changes in the structure of space itself. But even with early detection, humanity's options would be extremely limited. A black hole is not something we could destroy with current technology. We could not push it away with rockets. We could not stop its gravity. And we could not simply escape to another world with today's capabilities. The scale of the universe is far beyond human engineering. The nearest stars are separated by distances that are almost impossible to imagine, and interstellar travel remains one of the greatest challenges in science. But understanding a threat does not require controlling it. Throughout history, knowledge has allowed humanity to survive dangers that once seemed impossible. We learned to predict storms. We learned to monitor earthquakes. We learned to track asteroids and prepare for potential impacts. The same principle applies to space. Studying the universe gives us the ability to recognize what exists beyond our planet and understand the risks that come with living in a dynamic cosmos. A black hole entering the solar system is an extreme hypothetical scenario. It is not something scientists expect to happen. The nearest known black holes are incredibly far away, and space between stars is mostly empty. But studying such possibilities teaches us something important. The universe does not operate according to human expectations. It follows the laws of physics. And the more we understand those laws, the better we understand our place within them. The final reality. A black hole entering our solar system sounds like the ultimate cosmic nightmare. An invisible object with unimaginable gravity moving through the place we call home. But the real story is more fascinating than fear alone. Black holes are not monsters traveling through space, searching for planets to consume. They are natural consequences of the universe's most powerful forces. They are born from the lives and deaths of massive stars. They reveal the extreme nature of gravity. And they show us that the universe is far stranger and more beautiful than humanity once imagined. If a black hole truly entered our solar system, the outcome would depend on the details of its encounter. Its mass, its speed, its distance. The laws of physics would decide the future. Not myths, not science fiction, reality. And perhaps the most important lesson is not about black holes themselves. It is about humanity's relationship with the universe. We live on a small planet orbiting an ordinary star in a vast galaxy filled with billions of worlds and countless mysteries. Yet somehow, this small world produced beings capable of looking into the darkness and asking questions about it. We cannot control every force in the universe. We cannot stop every cosmic event. But we can observe, we can learn, we can understand. And every discovery brings us closer to answering the greatest question of all. What is our place in the universe? Because the greatest adventure of humanity is not escaping the cosmos. It is discovering it. If you enjoyed this journey through the world of black holes, and if you like documentaries about space, astronomy, astrophysics, scientific theories, and their factually correct explanations, then don't forget to like, subscribe, and turn on notifications cause your every like, share, subscribe gives us motivation to make for more realistic science documentaries. Thanks for watching Cosmic Frontier Studios.